We are asked to find the area of the shaded red triangle which is inside a square. The problem provides two key dimensions. The square has a side length of 4, and the circle has a radius of 1. To solve this, let's place the figure on a coordinate plane, with the bottom left corner at the origin. Since the circle is tangent to both axes, and we know its radius is 1, we can deduce its center, O, is at the point 1, 1. Now, let's analyze the triangle. It's a right-angled triangle, and its height is equal to the side of the square, which is 4. To find the area, we need its base. Let's call the unknown vertex E, with coordinate x, 0. The base is then 4 minus x. The key relationship is that the circle is tangent to the hypotenuse of the triangle. This implies that the perpendicular distance from the circle's center O to the hypotenuse point T is equal to the radius 1. First, we need the equation of the hypotenuse line, which passes through C of 4, 4 and E of x, 0. The slope, m, is the change in y over the change in x. Using the point-slope form with point E, we can multiply both sides by 4 minus x. And rearrange it into the general form x plus by plus c equals 0. Next, we'll use the formula for the distance from the center O to this line. The distance d from a point x naught, y naught, to a line ax plus by plus c equals 0 is given by this formula. We're using lowercase letters to avoid confusion with the vertices a, b, and c. By comparing our equation to the standard form, we can identify our coefficients. The coefficient a is 4, b is negative, 4 minus x, and c is negative 4x. The point, 1, 1, is the circle's center, and the distance is the radius, 1. Now we substitute these values into the distance formula. Let's simplify the expression inside the numerator. This simplifies to the absolute value of negative 3x over the square root term. Since x must be positive, we can remove the absolute value and rearrange. Now we solve this equation for x. Squaring both sides eliminates the square root. Next, we expand the squared term on the right. Rearranging all terms to one side gives us a quadratic equation. We can simplify this by dividing the entire equation by 8. Using the quadratic formula to solve for x, we find two possible solutions for x. We choose the positive root because x represents a physical coordinate. Finally, we can calculate the area of the triangle. The area is 1/2 base times height. This simplifies to 2 times the quantity 4 minus x. Now, we substitute our value for x into the area formula. And simplify the expression inside the parentheses. We arrive at our final answer. The area of the triangle is 9 minus the square root of 17. This is approximately 4.88 square units. So, the shaded triangle's area works out to be exactly 9 minus root 17, which is about 4.88 square units. That completes the problem. This problem showed how geometry, algebra, and the distance formula come together to find an exact area. It's a great reminder that different branches of math often work hand in hand.